Hello, this is Mrs. Ward. I'm going to go over the notes for section 7.6, inverses of a square matrix. So the rules for today are to verify the two matrices are inverses of each other. Then we're going to use Gauss-Jordan elimination to find the inverses of matrices. We're going to use the formula to find the inverses of 2 by 2 matrix. And then we're going to use inverse matrices to solve systems of linear equations. So when we first start, we have to talk about what an inverse is. So an inverse is something that undoes something in math. So the inverse of adding 2 would be subtracting 2. The inverse of multiplying by 2 would be divide by 2 or multiply by 1/2. So when you do that, when you do the inverse, you end up getting what's called the identity back. So in addition, if I'm adding 2 and I want to do the inverse, I would subtract 2. So if I take the positive 2 plus the negative 2, then equals 0, and 0 happens to be the identity for addition. Adding 0 to any number to the same number back. So when I read this definition to you for finding the inverse of a square matrix, you have to understand that that's what you're doing. You're going to find two matrices in such a way that when you multiply those two matrices together, you end up with the identity matrix. So one, by multiplying them, they undo the other one. So the identity matrix, and that's what this is, that symbol here, is something that has, looks like a reduced row echelon form without that extra column. So this would be the identity matrix for 2 by 2. The identity matrix for 3 by 3 would be this, and you would keep on going. Remember, the identity matrix will have that no diagonal ones, and then everything else in that matrix will be zeros. So if I take two numbers and multiply them by two numbers, two matrices and multiply them by each other, I'm going to get the identity matrix back if they are inverses of each other. Now you'll see the symbol here that means it's raising to the matrix 1. Well, that's what we do. That's our notation for finding the inverse. Remember that matrix, taking the inverse sign, cosine. And if I take 2 and I raise 2 to the negative 1 power, that's going to be 1/2. So the inverse of multiplying by 2 will be multiplied by 1/2. So it's a standard notation in math for an inverse that raises to the negative 1 power. So let's talk about how we're going to do these and what they're going to look like. So the first, and the reason why we have inverses in matrices, and they're so important, is because when we have matrices, we cannot divide. There is not a way that you can divide two matrices by each other. So if you want to undo multiplication in matrix world, you have to multiply by the inverse. And that's what this is saying. If I have AX is equal to B, so I have matrix A times matrix X, and that's equal to matrix B. And I want to find out what this matrix X is. If I want to solve for that, I'm going to have to multiply by the inverse. Because taking this A to the negative 1 times A will undo each other. It will end up being the identity, and multiply A by the identity and end up with it by itself. So in order to solve for X, I'm going to have to multiply this. And remember, when we talk about multiplication, the order that I'm multiplying is important. It has to be the inverse of A times B. I cannot flip that order. It does not work to take A times inverse of A. It must be in that. All right, so let's do some. So if I have this A negative 1, and so that's in the inverse is negative 1, 2, negative 1, 1, and I'm saying A, the original matrix is 1, negative 2, 1, negative 1, and I want to show that they truly are, in fact, inverses of each other. I'm going to multiply them. So I'm going to take A and multiply it by this. And what's fun, this is the only time that multiplication doesn't matter. If I take the inverse of A times A, I'm going to get the identity. If I take A times the inverse of A, I'm also going to get the identity. They're inverses of each other. So it doesn't matter that in this case I ended up taking inverse times A, and if these two are truly inverses, I'm going to end up with the identity. So remember when we multiply matrices, we're going to do that row 1, column 1 thing. So row 1, column 1, and I like to write this out as row 1, column 1. And we keep making 1 times 1 plus 2 times 1, and that'll be negative 1 plus 2, which will be 1. Then I'm going to do row 1, column 2, so I'm going to take negative 1 times down to column 2, which will be negative 2 plus 2 times negative 1. So that's positive 2 going to do row 2, column 1. So now I'm focusing on row 2, column 1. And I will have negative 1 times 1, 1 times 1. So that will be negative 1 plus 1, 0. And then row 2, column 2 will be negative 1 times negative 2 plus 1 times negative 1. So this is positive 2 minus 1 plus 1. Writing in matrix on that 1, 0, 0, 1. And that is the identity matrix. So I have shown that those two are inverses. And if I were to take an A and the inverse of A, if I were to plot the order of these two, I'm still going to get the same result. They're still going to be inverses of each other. I'm still going to get that identity 1, 0, 0, 1. So example 2 says I have the matrix 2, negative 1, negative 3, negative 1, and I want to see if it is an inverse of B. So again, it doesn't matter the order that I do it in. So I'm going to do negative 1, negative 3, and I believe on your notes this is a positive 1 times negative 1, negative 1, negative 3, negative 2. And I'm going to see if I truly get that identity matrix. That's what I'm asking myself. So I'm going to go on column 1, and I'm going to have 2 times negative 2 plus negative 1 times negative 3. So this would be negative 2 times positive 2 is 1. Now I'm going to do row 1, column 2. So 2 times negative 1 plus negative 1 times negative 2. So this is negative 2 plus 2 is 0. And I'm going to do row 2, column 1. So that would be negative 3 times negative 1 plus 1 times negative 3. So that's 5 to 3, negative 3, 0. And row 2, column 2 will be negative 3 times negative 1 plus 1 times negative 2. So that would be 3 plus negative 2, which is 1. So I get 1, 0, 0, 1. So I'm going to say yes. Say A and B are inverses. Okay, moving on to the next one. Next one, are these ones inverses? So I am going to multiply again. So I'm going to do 1, 4, negative 1, negative 3 times negative 3, negative 4, 1, negative 1. And I'm going to ask myself, do I get the identity matrix? So row 1, column 1 is going to be 1 times negative 3 plus 4 times 1. So that's negative 3 plus 4, which is 1. Row 1, column 2 is going to be 1 times negative 4 plus 4 times negative 1. So this is negative 4 plus negative 4, which is negative 8. So I'm going to have 1, negative 8. And I can stop right there because that's not going to be that 1, 0, 0, 1. Because I have that negative 8 there. So they are not inverses. If you had the burning desire to have closure, if it would continue multiplying, this would then 0 and 7. So they two aren't inverses. And then here's a question. Do all square matrices have inverses? I'm going to be curious. I'm going to ask you that question next week class, and let's see what you come up with. All right, next one, find the inverse of 2 by 2. So I don't want to just be able to run around and check and see if something is inverse. I want to be able to find it. And there are two methods to find inverses of matrices. For the 2 by 2, one is called using the augmented matrix. So when I do the augmented matrix, what I'm going to do is I'm going to put matrix A on one side and do those dots. I'm going to use to separate the coefficients from matrices. Then I'm going to put the identity matrix on the other side. Then I'm going to use Gauss-Jordan elimination, and what's going to happen is the identity is going to move to the left side, and then over here will be the inverse. So let's show you how that works. So I'm going to start off with 1, 4, negative 1, negative 3, and then put the identity, which is 1, 0, 0, 1. And then I'm going to rewrite the left side so it looks like the identity. So I'm following that same pattern that we've been doing for like every day now. That row 1, row 2 to eliminate my X, row 1, row 3. Same same thing except for only 2 rows, so I guess I just plus in this one. So when I add the two, like I would do row 1 and row 2 to eliminate this guy right here, I just have to add. So I'll do that off to the side. And when I do that, I end up with 0, 1, 1, 1. So that is going to be my new row 2. So 0, 1, 1, 1. And then my row 1 stays the same. Now I'm going to do row 1 and row 2 to eliminate the y. So I want to eliminate this 4. So I'm going to multiply by negative 4 to row 2. So when I do that, I'll have 0, negative 4, negative 4, negative 4, and then row 1, and we have 1, 0, negative 3, negative 3. Oh, negative 3, 0. Bad math. Alright, so here you go. I'm going to have 1, 0, negative 3, negative 4, and then 0, 1, 1, 1. So now the left side, this side looks like my identity matrix, and that's what I was trying to have happen. And then over here, this is my inverse. So I think it's A. So I'm going to say the inverse of A is equal to negative 3, negative 4, 1, 1. To check it, I can take this inverse, multiply it by this original matrix, and see if I truly can get the identity. What I do is I know. So that's method 1. Method 1 is using the Gauss-Jordan elimination of the augmented matrix. Method 2 is using what's called the determinant. The determinant only works for 2 by 2. And we haven't talked about a determinant yet, but we can go with that a little bit later on. The formula for the determinant is this right here. This right here, which is this AG minus BC. So that's the formula for the determinant, and this is when my matrix is A, B, C, D. So I'm going to go back to that matrix that I had up above. So that matrix was 1, 4, negative 1, negative 3. So when I'm doing that AD, I'm multiplying these two, and I'm going to get negative 3 minus, and then I'm going to multiply these two, because that would be my BC, and I'm going to get negative 4, and subtract this two. And when I subtract those two, I get a positive 1. This is saying find the inverse. I take 1 over that number, so I'm taking 1 over 1, which I know is 1. And then I have to do some funky stuff here. I have to take the matrices. The A and the D switch places. So this negative 3 and this 1 are going to switch places. So negative 3 here, positive 1 here. The B and the C, they have negative signs, which means they change signs. So here the 4 was positive, I'm going to now make it negative. Here the 1 was negative, I'm now going to make it positive. And then I multiply every element in here by that 1. So it's basically not going to change from 1. And that is going to be my inverse, which is the exact same answer I got from above. So let's try another one. Okay, so number 5, we're going to first find the inverse using an augmented matrix. So we're going to write down the original matrix C, and we're going to put the identity next to it. Now I'm going to look at row 1 and row 2, and I'm going to decide to multiply row 1 by 2 to eliminate that 2. So I'm going to have 1, negative 2, positive 4, 2, 0, and then row 2 is 2, 3, 0, 1. When I add those, I'm going to get 0, 7, 2, 1. So this, I want to make a 1, so I'm going to divide this side by 7, which means I'm going to divide both of these by 7. So when I do that, I'm going to have 0, 1, and then 2 sevens, 1 7. It's okay, fractions are okay, don't go. Okay, now I want to do, this method changed at all. Now I want to do row 1 and row 2 to going to multiply row 2 by negative 2. And if you have to use your fraction, or your fraction, if you have to use your calculator, I guess that's okay. But it's really not that hard. I'm multiplying by negative 2. So there's 0, negative 2. Remember when I multiply a whole number by fraction, I only multiply the numerator, so this would be negative 4 sevenths, and this would be negative 2 sevenths. And now I'm going to copy down row 1, which is negative 1, 2, 1, and 0. So this would be negative 1, and then this is a 0. This 1 I can think of as 7 sevenths, so this will be 3 sevenths, and then negative 2 sevenths. But this is a negative 1, so I'm going to divide everything by a negative 1, which means the signs are going to change. So when I do that, I'm going to have 1, 0, and negative 3 sevenths, positive 2 sevenths, and then this will be 0, 1, 2 sevenths, and 1 seventh. So again, this is my identity, this is my inverse. So my inverse, and you have to write inverse. So negative 3 sevenths, positive 2 sevenths, positive 2 sevenths, and then negative 1 seventh. So let's try this one with the determinant and see if we get the same answer. So I am going to do that matrix C, which is negative 1, 2, 2, 3. And the first thing I'm going to do is find the determinant. So I'm going to take negative 3 minus 2 times 2 is 4. So that is going to end up with negative 7. So negative 7 is the determinant of that matrix. Now to use that to find the inverse, I'm going to take the reciprocal. So that's this part here, taking the reciprocal. So that'll be 1 over negative 7. And now I'm going to do this part here where I'm rearranging the matrices. So the 3 and the negative 1 will switch spots. The 2 positive 2's will become 2 negative 2's. Now I'm distributing that negative 1 seventh times everything. Everything. So this will be a negative 3 sevenths, positive 2 sevenths, positive 2 sevenths, positive 1 seventh. And that is the same inverse that I did with the augmented matrix. Okay, moving on to the next one. So the next one I want you to find the inverse of 3 by 3. I have no choice. Well, I have lots of choices in life, but this is not one of those times. So I'm going to have to do the augmented matrix. There is no determinant formula. So I'm going to rewrite this matrix. 1, negative 1, 0, 1, 0, negative 1, 6, negative 2, negative 3. Doing the augmented part, I'm putting the identity matrix on the other side. Remember the identity matrix is that main diagonal 1, everything else is 0. Then running out the same thing that we did before, we're going to, let's see, no, like that. We're going to do this, and we're going to use that same pattern to eliminate, put the left side as the identity, and then the right side will be my answer. So it's long, it's tedious, but you know what? We're smart, intelligent people, so we can do it. So I'm going to do row 1, row 2 to eliminate that. So I'm trying to eliminate this guy. So I'm going to multiply row 1 by negative 1. So I'm going to have negative 1 times row 1, so this will be negative 1, positive 1. Negative 1, 0, 0. Copying down row 2, 1, 0, negative 1. I'm going to add 0, 1, negative 1, negative 1, 1, 0. Trying to make a little bit of binary code here. So row 1 has not changed. This is row 2. And now I'm going to do row 1 and row 3 to eliminate this 6. So I'm going to multiply row 1 by negative 6. So negative 6 times row 1. So this will be negative 6, positive 6, 0. Negative 6, 0, 0. Copying down row 3, 6, negative 2, negative 3. And when I add, I'm going to get 0, 4, negative 3, negative 6, 0, 1. Now what I'm going to do is I'm following that same pattern. I'm going to do row 2 and row 3 to eliminate my y. So I want this to go away. So I'm going to multiply row 2 by negative 4. So negative 4 times row 2 that, I'm going to get 0, 0. This will be a positive 1, which is kind of nice because I don't have to divide by anything. This is a negative 2, negative 4, and 1. So now that row is good. That is the bottom row of my inverse. And I'm going to move these two along. And I'll change them this time. Now, according to my pattern, I'm going to do row 2 and row 3 to eliminate my Z. So I want to eliminate this Z here. So I just have to add those two rows together. And I'm just going to copy down all this on this page. Alright, so this I can go off to the side and I could do row 1, 3, 0, 0, 1, 2, 4, 1, and then row 2, 0, 1, 1. So I'm going to add those together. I get 0, 1, 0, negative 3, negative 3, 1. 1, 0, and 0, 0, 1. Now, according to the pattern, I'm supposed to row 3 and row 1 to eliminate that Z. But it's already a 0, so I can skip that. I don't need to do that. So that's done. I'm going to push the very last step, which is to do 2 and 1 to eliminate the Y. So now I'm going to try and eliminate the Y. So all I have to do here is add. So I'm just going to copy it down. So row 2 is 0, 1, 0. And then row 1 So again, refresher, this is my identity. This is my inverse. To correctly write my answer, I'm going to say the inverse of A is equal to, and then copy this inverse down. Remember to check it on your calculator. You can raise it to, you can raise the original matrix C to check it on your calculator. Go all the way back up here to the original matrix, raise it to make it 1 hour. And when you do that, you do this. Okay, so we have another example. So this is example 7. I will pause this video and try it on your own and see how it goes. Hey, hopefully when you did this, this is what you got for your inverse is this right here. This one, you could do a lot of shortcuts. This ends up being a very quick problem. So I first took negative 3 times row 1, and I ended up with this, and that became my new row 2. And then I decided to eliminate this, so I multiplied it by 2. And that's me multiplying that by 2. And then I ended up with this as my new row 3. And at that point, I realized, at that point, I realized that this row right here, this is kind of like a cheat. But I realized right here that this one has a 0, 1, 0. So what I did is I just took it and I sort of put it in this, I multiplied by negative 1 and I put it in the second row. So that was 2/3 done at that point. And then I took the opposite of row 1, or sorry, the opposite of row 3, added to row 1, took the opposite of row 2, added to 1, and then there's my answer. Check on the calculator by raising the original 1 to negative 1. So now let's talk about how we use inverses to solve systems of equations. So when I rewrite the system, it says rewrite the system as AX is equal to B. So remember, A is going to be my coefficients, and B is going to be my answers, and X is going to be my variables. So what they're saying is you take the coefficient matrix, so 2, 3, 1, 3, 3, 1, 2, 4, 1, and you multiply it by your variables, which in this case are X, Y, and Z, and you get your answers, which are -2, coefficient matrix, the x is my variable, and then my b is my answers. My x, that's my coefficient. Now to solve it, this is like when we started at the very beginning of this video. I cannot divide a matrix world, so I cannot divide by this coefficient matrix. But I can multiply by the inverse. So remember we said we did A inverse times A x is equal to A inverse times B. So I am going to take the inverse of this and multiply it by my answer. So I'm going to take this 2, 3, 1, 3, 3, 1, 2, 4, 1, my coefficient. I'm going to take the inverse of that, multiply it by my answers, and that should give me my answer of x, y, and z. And what's good about this is I'm kind of going to, I don't want to say cheat, but we're going to use our calculator, I guess is the best way to say it. So I'm going to use my calculator to do that, and I just want to show you what you must show us when you are using the calculator. So we've got our calculators out. We are going to first put in that 3 by 3 matrix. Well, let's get to a page first, calculator. And so I'm going to hit matrices. So I'm going to have this matrix. I want to leave it as a 3 by 3 because it's just my coefficients. I'm coefficients in, so I'm putting in 2, 3, 1, 3, 3, 1, 2, 4, 1. And I'm going to, oopsie, I didn't mean to do that. And then I'm going to raise this to the -1 power. I'm going to hit enter, and I'm going to write down that matrix of -1, 1, -6. And so I'm going to write that down. Give me a second. Woohoo. So shall I cheat? So places the matrix raised to -1 power. I wrote the inverse down, which is here, and multiplied by 1, -2, and that's going to give me my answer. So when I hit times, I'm going to create a matrix. I'm going to go for that 3 by 3, hit enter, because that's the only one I can change the size. Remember, my answers has 3 rows, but it only has 1 column, so I'm going to knock this down to a 3 by 1, hit OK, and now I'm going to type in my answers, which are -1, 1, and -2. And when I hit enter, I get the 2, -1, -2, which is my solution to that system. I'm going to write that down. So 2, -1, -2. Sorry, right, -2, -1, -2. So let's do another one real quick. And I know I'm over my 30-minute limit, but here we go. So I am going to do the same thing. I'm going to write down what I'm doing first. So I want to rewrite it as AX is equal to B. So I'm going to rewrite it as 1, 1, 1, 2, -1, 2, -1, 3, -2, times my x, y, and z is equal to my answers, which are 2, 1, and -2. Alright, so then what I'm going to do is I am going to raise this to this, find the inverse, so raise this to -1 power, multiply it by my answers, and I should get my x, my y, my z. So when I do this, for x, y, and z, the x will be row 1, column 1, the z will be row 2. So now I am going back to my calculator, and I am going to do a 3 by 3 matrix again. It's 3 by 3. I hit OK. I am typing in those coefficients, which are 1, 1, and 1. 2. And then finally -1, 3, and -2. Raise this to the, why do I always do that? I'm just going to raise it to the -1 power. See, I have this answer is that guy, so I am fine. Hit enter, and I get that. Ooh, not very pretty. I'll be the first to admit it. I have some fractions going on there. But you know what? I don't care. I really don't care. I'm just going to I'm going to write that down so I get full credit. I'm going to write that down there. Fractions, fractions are friends. So I'm going to have -4 thirds, 5 thirds, 1, 2 thirds, and answer, which I'm just going to hit times, and it should bring that answer back to me. So I'm going to take this, I'm going to say times, so it takes the answer, which is that inverse time, and then my doing that and leaving that alone, knocking this to a 1, and putting in my answers, which are 2, 1, and -2. And when I do that, I get 3, 1, and 4. So I had fractions in the middle. It doesn't matter. My answers are nice whole numbers. I'm trying to make them, actually they're integers, they're not numbers. We can talk about that another day. So I'm going to have 3, 1, 4, which is my X, my Y, and my Z. So it is 3, 1, and 4. Either way you want to write the solutions, that is fine. Okay, I do believe we have one more. We do. So I'm going to pause the video. I want you to put in your calculator to come up with the same answer. Make sure that you're taking the time to write the steps. So you need 1, 2, 3. I know it's write your answer. So a second. So I did this all in one step in my calculator. I did not pause to write down the inverse. So this I took my coefficients, raised it to -1 power, multiplied it by my answers, and my solution would be x is equal to 5/4, y is equal to 0, z is equal to 5/2. And that is it. Okay, I hope this helps, and we will see you next time in class.